I expected actually more questions around, Neil, my bank balance keeps decreasing each month. There must be something wrong with your integration layer. That's an obvious question. But guys, Steve, thanks for the introduction. I'm Christhonie Geldenhuys, and you now know I'm from Cape Town. I've got a universal translator built into my name there. It's sort of pronounced like that. It was given to me, so that is how it is. But nice meeting all of you. And I want to talk a bit about security in a distributed computing environment, because as we evolve and our technology and our architecture evolve, we need to also think of security at the end of the day. And very often we forget about that, or we leave security right to the end. And for some of our businesses, security is quite important. So I just want to have a practical look of security. There's many people that can tell you more about the product. I'm not going to presume that I'll know that best. So I'll give you a bit of information of what we pick up as we work with some of our customers and what we see work. So maybe there's a bit more technical content to my presentation. So I'll look a bit about authentication and identity management and also authorization and rate limiting. So microservices have come up as a topic many times during this discussion, and that's definitely a buzzword. So how did we get here? So I want us to just think back of how did we get to this point? So we had this monolithic approach to developing software, and it was easy for the developers. All of our data was in one place. So I can go to the database, I can put referential integrity in there, and I can make sure that all of my data is in place. And what we started doing was we started building libraries so that we can break the problem down into smaller bits, but at the end of the day, our deployed artifact sits in one place. But as we decided to start breaking things up, maybe it's other vendors that came on board, we want to introduce them to our ecosystem within our organization, we had to adopt SOA, and the blocks became a bit smaller at the end of the day, and already these little cracks formed, and we then developed this glue to put things together again. And you can imagine, once you've broken something up into small bits and you now try to put it together again, it takes a little bit more effort to get that glue to work and make sure that the glue is of a proper quality at the end of the day. But now we sort of at microservices already, and now this problem is even bigger. More little blocks, I need to get them together again, and so our security problem then also becomes more difficult to solve. So another thing that we are evolving on is where we deploy our artifacts. So it used to be within the confines of our own organization, and I can remember the times when I got to my first job, there were strict protocols and the network was locked down and the internet cannot come inside, and now we've got these porous firewalls at the edge and that allow a certain extent of traffic in. We now put things in the cloud, and it puts us more at risk of people getting ingress into our solutions, maybe obtaining data and doing so much more. So how does these things impact security then at the end of the day? So the key considerations are still the same. We want to know who is using our system. We want to know what are they supposed to be able to do, and we want to sort of know when, or actually it's more how often they can do things, because we want to make sure we protect our investment, we want to protect our data, we want to protect our systems. Now, I had a discussion with somebody yesterday where we said very often in IT we think we've got all of these great ideas and technology, we've got these brand new ideas, but very often it's just rehashing stuff that we've seen in nature, seen in business. We've just invented new names for them. I can remember I saw bell-bottom jeans again, a thing, and I was thinking by myself, oh, my sister thinks it's a new thing, and we that are a bit older, we know it's just rehashing exactly the same thing. And security stays, the fundamental principles of that stays the same, even when we transition to this distributed environment. So let's take the first topic, which is authentication, making sure I know who is speaking to my system and how does this apply to our world. So now, in the traditional monolithic applications, we used to have our users, our roles, our groups, everything within one application, easy to maintain. We had a login screen, we've stored the data in our database. Then more applications came along, and if we didn't do it right, we would have had a username in the one system, another username in another system, and it creates a lot of confusion for us. And then if we were clever about it, we would have said, well, let's use something like Active Directory. Like, let's at least make sure we've got a single instance of identity and of authentication. And at least it started this pattern of I can log into many applications within my organization, and at least I can use the same username and password, and when the boss flicks the switch, my access to all of the systems stop immediately. So we can start thinking of then authentication as a service as well. I mean, we're making everything services already, so let's make this a service as well. We can have this argument of saying, well, let's put our authentication service as a trusted third party. We make sure that when we develop applications, when our client applications get developed, we trust the authentication server, and when the backend gets messages from us, we've got a way to prove that the authentication server has vetted us for who we claim to be. So then we get this centralized authentication concept. So we can put a product down like Identity Server that helps us bind this whole experience together so that in all of our applications we can have this single mechanism, and we can take login and authentication to some extent out of the organizations. We can centralize it and we can reuse that again. Now, I don't want to go into too much of the detail of Identity Server. The next presentation has much more in-depth information about that, but let's maybe just look at a quick overview of what are some of these benefits. If we've got a single mechanism, we've got common data. We make sure that the user data sits in one place. It's easy to maintain the user data. So if I want to go and update somebody's permissions, I can go and do it in the central location. Assign them to new roles and things like groups, for instance. And I can, with these tools, I can leverage existing security standards. I don't need to go and develop my own mechanism of how to log people in and how to go and do hashing of passwords and things like that, and making sure that my solution is safe. So when we use such a product like Identity Server, we can say, well, we've got a central logging function, we've got maybe centralized registration flows, because we might want to create like an onboarding process for our users. When somebody signs up on my portal, I want to at least vet that they're one of my customers or that they meet certain criteria. I can already put that into a solution like that, and now I don't need to go and develop that in each of the applications within my organization. I can go and say, well, I can go and do approval of authentication process, so I might want to send an SMS as an additional factor of authentication when more risky transaction is taking place, and I can have different flows. So now I can have a mechanism that sits in the middle, where I've invested this effort in connecting to an SMS gateway, for instance, or one-time PIN mechanisms, and I can leverage that in my applications. And it doesn't just need to be applications that's on premises. With certain patterns, you can implement that within your mobile applications, so that when you install the app, you could direct it to a login page of your organization, you authenticate at that point, and then there's mechanisms to make sure that the mobile app becomes authenticated and stores credentials and a token, so that you can use it for subsequent transactions. And a nice benefit of putting your authentication mechanism as a central service is you can also start getting a single sign-on experience. So very often at work, I log into many systems during the day. And I want to make sure that if I've logged in once, I mean, I just came to my desk, I logged in once. If I go to the HR system and then I quickly want to go and look on my webmail portal, if I can get that same authentication experience to flow from the one application to the other application, it makes my life easier. And when we have external applications, it makes our customers' life much easier. So single sign-on is just a mechanism where we redirect the user to a certain location where we can maintain, and typically it's done in the browser, so we can maintain the cookies in that session. And remember, your cookies are typically linked to an URL. So we want to make sure that that information lives at that identity. I've made it logon. acme.com, for instance, so that if another application redirects to that same page, I can use that session information there to sort of propagate through to the next application session. So there's nice benefits that we get out of that. And especially if we're used to building portal applications, you realize that we need to bring in some sort of a framework that brings all of these things together. Now I can maybe go and create applications in various front-end technologies. They don't need to all share a common technology stack, but they can appear as if they are acting as a single as an application. So I can go to my purchase order system, and I can click on a hyperlink over there, and it takes me straight to the user information in another system, and I get this seamless user experience. So that's definitely a benefit. Radio. And when we start doing these things, we need to start thinking of what are we now going to do with this data? Because in the past, we had the users and the groups and the roles and the permissions all in tables within our one application, and now we need to find a way to break these things apart. And again, the patterns are still basically stay the same. We keep our users and our groups in our central infrastructure, and we make roles and permissions, we make a application domain concern. And then we use references to the entities in these various systems to just glue the things together. And then at the end of the day, we can use a common API to get information about the user and information about the security. An interesting a development recently is more and more emphasis on privacy of information. And if we think of the South African situation where we look at the POPI Act, if we centralize user information in one place, we can actually benefit from putting mechanisms in place so that we can manage the distribution of user data through a single solution. Because if we keep storing the user's personal information in 10 different systems, we need to maintain that consent in 10 different places. And if a user asks us to update it, we need to manage that synchronization. So let's say we look at POPI. I've got a little slide on that, but I think we all know by now what it is about. So what if we can then access personal information in a central location? And we say, well, this information is stored once. We have got an easy way to add information to it. We have central control over it, and the customer can start maintaining his own data within that solution. And we can also ask the user consent for whenever we want to use that information, let's say in the purchase order system or in the ordering system or the HR system. We can simply ask the user consent like we should to use it in that area. And if we look at Identity Server, it already has mechanisms in place to capture user information when the user maybe signs on by themselves. We can build customized forms to capture these fields that I've got on the screen over here. And then we can have mechanisms where we say, well, okay, I now want to use your first name and your last name and your email address and maybe your date of birth inside our HR application. And we can create then mechanisms where we can ask the user consent, share the consent rights with the other application, and your applications can then on request go and call this information from a centralized API. So when I decide to remove my consent, so I phone up my organization and say, listen, I don't want you to share my date of birth, it's very special to me. Can you please remove it? I can remove that consent in a central location, and then the other applications don't have access to that anymore. So that's actually a very nice side benefit of following this type of pattern. So in WSO2 Identity Server, we already have support for this. We have mechanisms where we can assist the user to create their profile and to maintain their profile. We've got ways of going into the application and do API calls against user information. We have mechanisms where the consent can be managed then by the user or through other applications. And there's actually a very nice portal application where if we've now centralized this, we can give people access to our user portal page where we can change passwords, where we can change our personal details, where we can see who is using, which systems are using our information. So I find this actually a very handy mechanism. So let's look at then authorization. So how do we get this now done? So how do we get this permission of what I may do in the various systems, of what I may do shared amongst the various systems? So we've got standards like OAuth, which is a token-based mechanism where I go to my authorization server and I get something that can prove that I am who I say I am, and it's trusted by downstream parties. So think about this as sort of like a key. Oh, I don't want to be at that slide yet. Like a key made out of ice. Because I want this thing to expire after some time. I want to be able to gain access to a door, but I don't want to have this key all the time. And the reason for that is I want to be able to refresh this key because I can lose it or somebody can eavesdrop in on my communication and take hold of that. So I want to make sure that the key gets refreshed often. I don't want to use my personal login credentials each time to achieve that login, because each time my username and password goes over the wire, there's yet another opportunity for people to inspect that and intercept that. So the whole mechanism for OAuth is then to create this key, and then I use something like an API manager to give me this first point of entry. I call it my first line of defense. So now as I develop services within my distributed application, I don't need to go and authenticate that this user is able to use this API each and every time. I can offload some of that responsibility to a centralized infrastructure like the API manager. So how do they get done? We can have an access token, for instance. It's like a string we put in the header of our API calls that can identify this session. We might want to go and look this up. So, because imagine I'm a back-end system and I now get this token. I don't know who's behind it. I don't know that it is actually Nick. I need a mechanism to go and say, well, I've got this token that I've received through my API call. Who is what's the first name and the last name of this person, and what roles this person has within my organization. So this is one mechanism of doing that. Another mechanism that we can use is we can use JWT tokens, which is a bit of a bigger payload. I put a little example of that in there. You still put that in your API call, and it consists out of like a header section, a payload section, and a signature section, but it's quite big. And within this token is the claims of the user. So when we authenticate, we get this bigger token back, and this bigger token is a self-contained unit where I can access information about the user in the token, and it's signed in a way so that I can make sure that my identity server has actually issued it to me. Now, what we then sometimes forget is that there's different benefits and drawbacks of these two approaches. And like in a typical scenario where you compare these two, the benefits of the one is the drawbacks of the other one. So what we found works very effectively is using access tokens where we've got very chatty API calls, because the token is nice and small, it doesn't use up a lot of bandwidth, and it's easy to manage. If I look at the JWT tokens that I mentioned, they are quite big. They've got a lot more information in there, and I can go and verify them through their signature to make sure, so I don't need to make any API calls. But they become so big that if you've got a chatty interface, or you've got a mobile device that works on mobile networks, your token becomes bigger than the payload of the message. So then in these type of scenarios, that choice of mechanism might then not be the best solution. And then you can use things like the API manager to receive access tokens at the API level, convert them to JWTs within your organization. So as you go from one microservice to the other one in sort of cascading calls, you can tag along the credentials within your infrastructure, and as you go out again on the external network, you can swap back to something like access tokens again. Something very important to do is you also need to make sure that you trust the endpoints that you negotiate authentication and authorization with. And very often I see some of our customers forget about key things like using security certificates. HTTPS is actually quite obvious when we talk about security, but we don't necessarily check these certificates all the time. Remember, we don't need to use the certificates that we get for our browsers because it's systems talking to systems. I want to explicitly trust company A's system when I go and interact with them. I don't want an external party like VeriSign to have verified them in any way when it comes to an API call. So I want to be able to import your certificate into my world, and I want to make sure that when I speak to your organization or I speak to my identity server, that token actually came from there. So I will definitely make sure that when I do these calls, make sure those checks are in place. And also when we use JWTs, we must make sure that how the token is signed is actually valid. And keep in mind, when we've got a cluster of servers, each of our servers might have a different identity, might have a different certificate, and sometimes these mechanisms become difficult to figure out, is this server actually one of our servers? And then we must also think of this chain of responsibility that we can do with root certificates and intermediate certificates and maybe server certificates, where we need to look up and make sure that whether the certificate I got, I might not know the certificate I've just received now, but is it part of my organization's certificate chain? And these mechanisms you guys must also think of whenever you implement these checks. And very often people ask me, well, which of these OAuth flows must we use? And I just thought it handy to maybe put something on the board over here, because not each authentication flow is applicable for each situation. There's a very nice web resource at oauth0.com where you can actually go through a decision tree to sort of see when I've got like a single page application or I've got a mobile application, which is the correct technique that I should be using. Client credentials might work in one situation, but when I get to a mobile device, I need to start thinking of other things as well. So so something I typically recommend to people is follow these guidelines and make sure that you use the appropriate technique for your situation. And the last topic I want to talk about is about security. We want to make sure that we protect our investment in terms of how often people can speak to our services. We find a lot of situations where people abuse services that are exposed on the internet, and you want to make sure that your backend infrastructure do not suffer from those from high load attempts. And keep in mind, high load might be a function of valid business requests or lookups, or it might be malicious at the end of the day. An API manager builds within the solution a mechanism to protect your back-end systems from excessive load. And what you want to go and do in this specific situation is you want to make sure that when your back-end systems are maybe pushed to their limit, that our API manager or something in front shields off some of these transactions to make sure my backend system do not get overloaded. Because the last thing you want to do while you're already under load is to deal with high load situations. So by using the API manager, we can continuously monitor traffic as it goes through our solution, and we can then act on various triggers that might identify high load situations. And there's a very nice document in the WSO2 manual about their throttling policies. And what's interesting about this is the API manager don't just throttle on an API level. It can actually identify your session and throttle your specific session so that an individual user do not abuse your service. You can go and say, listen, I might even allow a user to burst a bit of traffic within my backend system, but then I want him to, on average, settle out. And there's a mechanism, that sort of second block from the left, that handles with that. And then I can define API level throttling, where I said this API should only be able to deal with so many requests. And you can also, when you subscribe to an API, you can subscribe to an SLA level where you say, well, I want the 100 calls per second subscription, and maybe that can come at a premium price where you can build that into the solution. And you can even go and say, well, get requests get higher priority over, let's say, for instance, put requests. And it's very fine-grained in how you can manage the throttling of your APIs. A last point that I want to mention is that you might have a cluster of backend servers, and you want to make sure that you distribute the load amongst all of them. So there's even a rule in the throttling policies where I can say each backend instance is allowed a certain amount of traffic. So let's just summarize what I was talking about in terms of this topic. I said, well, now that we've got smaller little building blocks, let's leverage authentication as a service. Let's put a mechanism like identity server in place so that we can store that information in a central place, and we use APIs to gather that information. We've got a mechanism in our world where which is a combination of identity server and API manager, where we can manage authorization between our APIs in a very innovative way, and also bundled into that whole mix is rate limiting. So that, in summary, is our observations for security in a distributed environment.
Any questions for Christhonie? We've got two. Bring the mic here, please, into here.
I must say, I prepared a 1 hour presentation, and just yesterday I found out, now I actually have 30 minutes for this whole thing. If I was talking maybe a bit too fast, I didn't get the signal to slow down yet.
Thank you. I'm not sure if I missed it in terms of the authentication. I just want to pick your brain in terms of the risk part of it. For instance, if I make an example, the single sign-in authentication and the keep me signed in setup that usually pops up.
Yep.
Yeah. And now, for instance, if someone gets access to my Active Directory, then in a way they have access to my entire Office 365 apps, for instance.
It's important to note that a product like Identity Server fronts your user stores like Active Directory. The user will never have direct access to that in any way. So we provide an industry standard API for users to try and authenticate, but the backend implementation is hidden from your external layer, both behind a firewall, one thing, but from an application and process and implementation perspective, that backend implementation is hidden away, and there should be no risk in terms of that. It doesn't look like I answered this question correctly.
No,
So
it's fine. Maybe we'll take it over during the break. It's fine. Thank you.
Okay, super.
Why are you letting him off so easy?
I think I had a very boring topic then. When you talk about finances, everybody picks their ears. Huh? That is the thing.
And my question is this. So the identity server can provide authentication as a service, right?
Yes.
Meaning there'd be a REST endpoint that I'd be able to call, let's say from my Angular application.
Yep.
And then build my custom login page and then pass the credentials and then get a token back from the identity server. Is that how it's supposed to be? Instead of using the WSO2 login page by the default one.
I would, if we look at these patterns, and specifically I would point you to the OAuth0.com webpage for good patterns and processes on how to do that. The typical pattern is to actually redirect away from your application, let your authentication service handle that process, because you might not know exactly which steps or factors of authentication the organization has now configured this user to go through, and you can now have adaptive authentication where if I log in frequently, I might be prompted for a single factor, but when I'm a first-time user, I will get an email activation link, or I might get a one-time PIN and things like that, and you don't want to deal with that complexity within your application. So the key here is redirect away from where you are, let that application handle it, and when that redirect comes back, there are evidence in that redirect, which is typically the tokens I talked about, that will prove to you that a successful authentication attempt has been completed.
And also, you spoke about the backend APIs or applications. How do you verify that token that was generated by the identity server, that there was no man in the middle attack, or that it actually came from the identity server?
Okay, so there's two techniques that I briefly maybe touched on. The one is if you receive an access token. Yes, by all means, you might be behind an API manager and it did the first pass of authentication for that token, but you might want to know which groups this user belongs to. There is a dedicated endpoint provided on products like Identity Server where you can introspect that token, and based on configuration, the server will return certain user claims back to the application where you can then make decisions on. However, if you've received a JWT, which is this bigger token, there's mechanisms where you can validate that the signature within that token is valid and came from your identity server. And since you know the identity of that server and its certificate, its public certificate side, you've got a mechanism to ensure that that token was not tampered with or there was no man in the middle situation. Okay.
Anybody else? Okay, thanks, Christhonie.
Thank you, Steve.